So I'll just broadcasting.
Yes.
Great. Okay. So I'm really happy to introduce our first keynote speaker of the conference, which is Vivian Chen. So Vivian got her PhD in 2015 from Carnegie Mellon University, and she's now working at the National Taiwan University, where she leads a lab called Machine Intelligence and Understanding Lab. She's worked on many aspects of spoken dialogue systems, done a lot of work on deep learning approaches to task-oriented systems, which I'm really excited to hear about. So thank you very much for kicking off the conference. Over to you.
Okay. Hello, everyone. I'm Vivian Chen from National Taiwan University. I'm very happy and honored to be invited here to give an in-person presentation within the 3 years. This is my first physical conference within the 3 years. So I want to share my stories from my experience, also related to 3 aspects for conversational AI. And please feel free to ask questions in the middle of the talk or end of the talk. So I think every one of you is familiar with this figure. This just shows the classical task-oriented dialogue system framework. Usually, you will build several components to finish a conversational system, starting with the ASR and understanding. And usually, if you start building this system, you will start with the first component, which is language understanding. This is most important part because that is the first component in this pipeline. But you will face a first challenge, which is about robustness. Let's look at this language understanding component. Actually, the input from the language understanding comes from the ASR output, which means sometimes you need to take care of the ASR performance. If you do not have the good ASR output, then your natural language understanding model may not be able to get very good performance. I think everyone may have this experience, especially from industry. And also we know that recent advances in NLP are based on a lot of pre-trained models such as Elmo, BERT, Roberta, and so on. And prior work, just consider to directly take this pre-trained model to our target scenario, which is the spoken scenario. However, there's a question. Is it possible to take this pre-trained model to our target task? I think it's a little bit weird and not that reasonable because the pre-trained model originally looked at the sentence in the text form, but you want to use them in spoken form. The spoken form, which is come from the speech signal. So this pre-trained model did not hear of the sound of the sentence. They just look of the text. If you imagine you look at this sentence, live of lights to Morocco. I think it's a little bit difficult to capture the correct meaning of this sentence, right? Do you think it's reasonable for this sentence? But if you think of the sound of this sentence, actually the original sentence is list of flight tomorrow. If you think of the pronunciation of these 2 sentences, you will figure out because of the sound are very similar to each other. So ASR output may misrecognize the one into another. If you only take the text form, it will be problematic. The reason is there's a mismatch between written and spoken format. We are pre-trained on the written text, but we are testing and fine-tuning on the spoken scenario. The spoken text includes some misrecognition error. So our goal is it possible to improve the robustness to make it more robust to ASR errors, which is target for spoken scenario and can have better performance especially your input are spoken language. So we figure out a solution which is called lattice linked model. I'm not sure whether you are familiar with lattice or not. Actually, lattice is the complex and informative structure output from ASR system. In this lattice, we have several paths, and usually the recognizer only output one hypothesis with the highest probability. However, other paths, although they have lower probability, but they probably contain some correct word. So if we can use this structure, then we may have higher probability to guess the correct meaning of the sentence. Prior work already showed that if they take the lattice information and to run the unknown type of model on the spoken language understanding task, they can get improvement. And these days, we know that we can benefit from language model pre-training. So we think of a simple solution combining these two paradigms. We want to utilize the lattice and also pre-training technology called lattice linked model, which is very simple. We just take the existing pre-trained model. Usually that pre-trained model are trained on natural language, the sequential text. And we do the second pass pre-training based on the lattice. So the idea is we want to predict the next word, right? Just like the language model pre-training, but the next word will come from the lattice format. And we have the corresponding probability from the transition age. Like we have 80% probability to sample this word will be the next word prediction. And this word will have the 20% probability as the target word. And during the fine-tuning stage, we can also leverage this complex information to help us figure out the correct semantics. And we can easily compare with the 3 different baselines. The first one is we only take the first hypothesis, like the one best result. And the second one is we leverage the pre-trained model. And the third one is we leverage the speech signal from lattice. These 3 are our baseline to compare with. And we conduct intent prediction on 2 benchmark data sets. And you can see that SNP's data set has the higher word error rate, which is more challenging to deal with. Let's also show that our lattice linked model outperforms the 3 baseline, especially when our word error rate is higher. To compare with the SOTA BERT model, previously, we see that in SNPs, we can outperform the BERT model. However, the ATIS data, because the word error rate is relatively lower, so the performance, we have comparable performance with the BERT model. But if we consider more complex scenario like the conversational data, we do the experiment on these 2 data sets, MRDA and switchboard. They are more complex, so the word error rate will be higher. Then our lattice linked model will have much improvement. However, after we present this talk to a lot of audience, they usually have the question about, your solution seems really good. However, actually, we do not have this lattice information because usually we just take the off-the-shelf ASR and they only output maybe 1 hypothesis or multiple hypotheses, but we do not have that complex structure. So if we only have this text from ASR system, is it possible to have any solution to mitigate the errors? So we try to figure out another solution, which we don't need the speech-related features, which is called contractive learning approach. The idea is also very simple. We want to adapt the embedding for a sentence and make it more robust to the misrecognition, but only consider the textual information. Here is the pre-training strategy. In the pre-training, we can directly take any type of speech corpus for ASR. It usually contains a speech utterance and the corresponding text. So we just take this speech utterance and put into the off-the-shelf ASR and get the ASR output. And we want to do some adaptation in pre-training. During fine-tuning, we have the target task. Target task is the SLU task. So we have the speech signal and also SLU label. And the speech signal, we can also get the off-the-shelf ASR to get the output. And we want to fine-tune them. So we want to do contractive learning for both pre-training and fine-tuning. During pre-training, we propose contractive pre-training to learn the embedding for spoken scenario. As I said, we have the clean text and also the ASR output. So the idea is we want them to have similar embedding, because if they have similar embedding, actually, if we get the ASR error, it doesn't matter because they also will produce the same distribution of the label as the cleaned one. And we also take the negative pair from other speech utterance and take the contractive learning to make the sentence from the same speech close to each other. So this is our pre-training objective. We combine with the mask-linked model. Let's take a look of the performance for pre-training strategy. And we conduct three different data sets. Actually, the slurp data is the latest SLU data with a large scale, and also the label is more complex. They have a large set of labels for prediction, so it's more challenging. We compare with three baselines. The first one is the Roberta baseline, and the second one is the phoning BERT. They use the additional phoning information to mitigate the recognition error. And the third one is called SigCSE. And if you work on NLP area, you must be familiar with this one because that's a popular approach using contractive learning for sentence embedding just by swapping the dropout layer. Our proposed pre-trained model actually improved the performance for almost all baselines, but slightly worse than the phoning BERT in track 6. But the phoning BERT used additional features from the speech signal, but we only take the text. We only need the text information. So this is the pre-training strategy. We also have the room for improvement during fine-tuning. So in fine-tuning, we want to also apply contractive learning in a supervised way. This is a classical supervised contractive learning approach. During fine-tuning, you will have the sentence and also the corresponding intent. The sentence is output by ASR, so they may contain some errors. And original supervised contractive learning is that based on the intent label. For example, these two sentences have the same label. We want them to have similar embedding to each other. And for utterance with different label, we want them to be far away from each other so that they can have the similar distribution for the output. This is a very simple idea. This is also a classical way to use supervised contractive learning. However, in the spoken scenario, this will have some issues because sometimes this sentence may contain some recognition error, right? It's output from ASR system. So misrecognition may lead to wrong or vague intention during fine-tuning. For example, if we misrecognize the keyword of this sentence from on to off, originally this sentence is turn the light on, but we misrecognize into off. but the label is intent should be light on, right? So during fine-tuning, we will force the label distribution similar to this one as the ground truth by using cross entropy, right, during fine-tuning. However, this is a little bit weird because we just force this sentence to have this distribution, which is light on, but the sentence in the text form is turn the light off. So this is not reasonable if we directly apply fine-tuning. So we consider the self-distillation to mitigate these issues. The self-distillation is that based on the sentence itself, actually during the fine-tuning strategy, we have the probability distribution smoothly changed. We don't want them to change a lot to the target distribution, but they should similar to their previous prediction during fine-tuning iteration. So we add additional objective, which is the KL divergence between these two distribution similarity, and making the label distribution also need to similar to the previous iteration in order to mitigate this misrecognition scenarios. And this noisy label can also affect the supervised contracted learning. Let's take this as the example. We have 3 sentences, and the first sentence has misrecognition from on to off. So the intent will be light on. And these 2 sentences are correct. So in the supervised contracted learning, as we said, we want these 2 vectors to be close to each other, right? Because they belong to the same intent. And we want this one should be far away from this one because they belong to different intents. But this should not be correct because based on the sentence itself, turn the light off should be more similar to can you turn off the light compared to turn on the light. So we replace the original part, like whether this 2 sentence has the same label as the soft value, which is the similarity between 2 distributions. It means that based on the previous iterations distribution, we will find out this one, the first sentence will be more similar to the third sentence based on the sentence itself. So we will have 0.7 for the first one and the third one, and 0.3 to replace 1 in the previous objective. So we have the soft objective in our fine-tuning strategy. All of this objective is try to mitigate the misrecognitions. So this is a whole objective, including original cross-entropy during fine-tuning and self-distillation and the hard objective and also soft objective. Adding this fine-tuning strategy, we can greatly improve the performance for all baselines. And we show that we can significantly improve the robustness, not only to ASR error, but also to label noise. So in this direction, this is first story. I think if you have your own ASR system, you can take more complex and informative speech signal because they may preserve some uncertainty. You can use lattice language model. But if you do not have such information, only have the text, but you can also mitigate the recognition error by contractive learning for both pre-training stage and also fine-tuning stage. And move to the second story I want to share, which is about scalability. Actually, after we finish the natural language understanding component, which is the first component, we move to the second one, which is dialogue state tracking. It's also a very popular task during our community. However, building a training data for dialogue state tracker is very difficult because you need to collect the whole conversation and make the annotation through the conversation level. So usually people just work on dialog state tracking, focus on some existing benchmark like multi-arts or SGD dataset. However, if you want to build your own dialog system, you may not have the corresponding dialog state tracking data. You need to collect by your own. And it's a little bit difficult to collect the large scale of the data. So the scalability will be the issue. So we want to address these scalability issues because we do not have enough label data. And prior work, they already show that data augmentation is a very simple strategy. And this work is also will be presented in this afternoon. So if you are interested, you can go to the poster session to get the further details. And I just describe the idea of this data augmentation framework. So let's look at this conversation. The user wants to request a restaurant, and the agent suggests a restaurant by some attributes, and the user declines the suggestion and makes some constraint about the restaurant. This is our conversation with the label. So how to do the data augmentation? For naive way, it's very simple to think of this solution, which is value substitution. We can just easily replace the slot value from British to Chinese, then from 18 to 70. So we can have the same text format with different slot value, and we can open our data and make the state tracker more robust and general to different type of value. Definitely, it's a simple strategy, and everyone knows that. And prior work, they proposed COCO approach, which not only replace the value, but also replace the slots. They have different slot combination. For example, original combination is restaurant food and restaurant time. They replace it with restaurant food and number of people, and they generate the corresponding sentence. So they augment the data in slightly different way. They have more complex slot combination and make the state tracker more general to different slot combinations. But if we only consider slot weight and value weight, I think it's also not enough. We want to make it more general because the user behavior are more complex. So we propose to augment the data by more diverse user dialog act. For example, original user's behavior is to decline the suggestion. And we can have the probability to accept the suggestion. And also, we can allow the user to make the request about another domain, and also can have capability to do co-reference and make the slot value more general, including the Boolean type, not only the span-based slot value. And how can we augment our users' dialog behavior? Let's take a look of this example. It's very simple. We have the system turn, and the system makes some recommendation and request some. I'm not sure whether you can see this one. Let me. Okay. Oh, okay. Let me put it here. Okay. And also request the restaurant time. Okay, so we check the current system dialog act. System recommended something, and the user has a certain probability to accept this suggestion and also refuse it. If they accept this suggestion, we just put it into our dialog state. And for each system requested slots, we think user may have certain probability to reply the values. If they decide to reply, we just add this slot into our informed set in user state. And user will also have a certain probability to change the domain. If they want to change the domain, we just randomly sample a domain and also corresponding slots. So after that, we decide the slot the user want to inform. And the next stage is design the value. The value should be very simple, like we can directly sample from the dictionary, but we allow the co-reference. Because in our informed slot, we have the hotel area and we also have the restaurant area. So the user can directly use co-reference to indicate the same area, like near the restaurant, which is about center, and others, which is random sampled from a dictionary, to form the final dialogue state for the user. After we have this dialogue state, we can just combine with the system utterance and generate the corresponding user utterance. And in this way, we do Bing search to get diverse sentence and also check whether this generated utterance align well with the input dialogue state. We check whether this slot appears in the sentence or not, and also check whether the value is consistent with the input or not, for span-based and for Boolean. In our strategy, we have 78% of success rate for generating qualified sentence. And for prior work, they only have 57% of success rate for generating the qualified utterance. It shows that we improve the efficiency of data augmentation. This is just our whole framework. We call it CUDA, Controllable User Dialogue Act. Actually, we get some review. The reviewer said this abbreviation should be considered a little bit because CUDA already means other things, but we cannot figure out other way. I think it's more easy to remember, so we still use CUDA in our framework. So let's take a look at the result. Compared with previous work, we can improve the performance just based on our augmented data for diverse state tracker. And we also achieve the SOTA just based on our augmented data. So it can be used for different type of tracker. If you improve the tracking model, you can also use our augmented data to get further improvement. And we also check whether our augmented data have better robustness to consider diverse dialogue scenario. And we test on COCO plus data. The COCO plus data set is a rare slot combination data set. So it's more challenging. So you can see the performance is lower, especially for trade. And we can also improve the performance more for the multi-orgs. So this is the scalability part. We show that this is a very simple idea, but we can augment the data with diverse behaviors. We see we can improve the efficiency for data augmentation, so you can save your time, and more general to different data sets and domains. Actually, we achieve the SOTA performance, and hopefully more advanced tracker can also use to get further improvement. And we also show there's a potential to be used for different user simulator because they can generate different type of users behavior by our framework. And let's move to the third story. The third story is more challenging because after we think we can build a reasonable task-oriented dialogue, we just talk to a company and say, oh, we can build a task-oriented dialogue for you, and we have enough background to do that. And the company say that, but we don't need the task-oriented at the time, but we have a lot of tasks involving a lot of conversation, which is the conversation between a salesperson and the customer. And the salesperson can create a lot of business opportunity for us. Can you build a dialogue system that can behave like a salesperson and to create more business opportunity, which is a practicality dimension. So we just look at the salesperson's job. Actually, the salesperson is trying to discover the business potential. Usually in the beginning, they just do chatting with the customer and figure out what kind of business related intention behind this customer. And then they can smoothly promoting the related product through the conversation. If you think of your insurance agent, probably you will figure it out. So our scenario will be the conversation will start with chatting, but smoothly transit to task-oriented domain. So we need to figure out there's a business potential in the chatting scenario and move to the task-oriented. However, this is very challenging because I think it involves two types of dialogue system, open domain chatting and task-oriented one. And previously, I only focused on task-oriented one, and a lot of group only focus on the open domain chatting to do more engaging conversation. But these two directions are developed independently in different ways due to the objectives, due to different objectives. And in our task-oriented scenario, we assume the user will have the clear goal in the beginning, but actually during the conversation between salesperson and customer, in the beginning, the customer may have the clear goal, so they cannot make the clear request for some task. That's why we propose SalesBot to transit from open domain to task-oriented scenario. We assume we want to have a dialogue start with open domain chatting. And this is an example generated by BlenderBot. They just chat to each other. And in the middle of the conversation, the user said, oh, they like movies. And we hope we figure out probably we have some business potential to sell the movie ticket. So we just gradually guide the user and try to make the movie ticket booking for them. If we have such data in a large scale, we can easily train a conversational agent, and hopefully they can already have the salesperson's capability. But the challenge is we do not have this existing data set, right? So we decide to simulate these scenarios so that we can get unlimited data. Currently, we have a really good Blender bot as the open domain chatting, and we can easily generate a large set of open domain chatting data. And we fine-tune the Blender bot for task-oriented domain, so we can also generate a large set of task-oriented domain data. But how to bridge these two types of conversation? We want the conversation start with open domain, but gradually change to task-oriented domain, like a salesperson. So this is the framework. You need to do the transition. It involves two challenges. First one is, what is the good timing to do the transition? And how to do that? For timing, when we propose intent detection to detect implicit intent. And how to do the transition, we just generate the transition term. It seems very simple. Let's take a look how to do that. The intent detector tries to identify whether this user is likely to have some task-related intent. You think building an intent detection is really simple, right? You just get the data, and to train the intent detection, it's just done. But if you look at the existing data set, the intent will be explicit intent. The user directly mentioned their request. They want to check some landmarks, so it belongs to find attraction. But in our scenario, the user may not make this request. They just say, oh, I like France. I never visit there. either it's a good place. So the intent is not clear. We just think they have some potential of interesting in getting attraction. So we do not have this data. If we do not have this annotated data, how can we build the intent detector? We designed to use QA systems capability to do zero-shot inference. Like we take a well-trained QA and take the conversation as the input and make the natural language question related to the intent. If the intent is find attraction, we take the description of this intent and make a natural language question to ask the QA, well-trained QA model, and whether this user have this potential to do these things. If the QA model say yes, or we think probably we have this probability to do this transition. So this way is very simple, but not easy, because this reasoning may require some common sense understanding, because you need to know France and Paris is related, so we can suggest Paris landmark for them. So after we figure out how to detect the timing, we need to generate the transition term. And thanks to the author's data, they already have some data set for us to do this generation. Actually, author's data is the transition term generation task. They try to bridge the source topic and the next a target topic by a topic connection through the knowledge graph. So we want to utilize this idea to bridge our open domain chatting through the task-oriented scenario. So we input the previous sentence and the next sentence, and we generate the transition term. For example, if the user mentioned they like popcorn, and we think popcorn is related to movie, so we can say, oh, so what kind of popcorn you usually eat during watching movie? So we can gradually mention movie things and try them to book the tickets. So this is just the whole framework from our approach. So in this approach, we can generate unlimited data. The unlimited data all transit from chit chat to task-oriented, like a salesperson. And we can use this data to train your end-to-end model with the salesperson's capability. But what is the quality of this dialogue? Because this just generated, is it reasonable for us to as the training data? So we measure the quality about whether this suggested service is related, and also whether this transition is too aggressive or not. We hope lower is better for aggressiveness, and also the overall conversation. If the crowd say the overall quality is reasonably good, it means that this can be a good example for the sales beginner. We can see that after we collect the cross annotation, we think we have reasonable relevance and overall performance, and also aggressiveness is neutral, but we still have room for improvement. We want to lower the aggressiveness by using more transition term probably, and also make the relevance improve. Here is the third story for practicality. We use SalesBot to simulate unlimited data for this scenario to bridge these two types of agents. And our dialogue express reasonable quality, and the data with the crowd annotation, and also our framework, the simulators, can be used for training end-to-end agent in supervised way or reinforcement learning way with sales behavior in order to improve the business potential and to increase the practical usage. Here is 3 stories I experienced from my experience before. And I think we hope every one of you in this dialogue community can understand, actually we have a lot of challenges in real conversational system, but we are making progress to make it better and more scalable and practical. And thanks everyone. I'm ready for taking questions.
Thanks very much. Really enjoyed that talk. I have a mic here for anyone who would like to. Is this working? Hello.
First of all, thanks for a terrific talk. It was very interesting. I had a question on one of the latter points on annotation regarding the sort of aggressiveness component. That feels like something that might be relatively variable annotator to annotator, culture to culture. How did you sort of see the annotator agreement working out in that case, and how did you cope with that?
Okay, I see. For the annotator about whether this transition is relevant or not, right, and aggressive or not.
Right. Specifically, I guess the aggressiveness sounds interesting to talk about.
Actually, the aggressiveness, I think it's a little bit difficult to get agreement from the annotators. But I think our current strategy is not that good because we only take one turn to do the transition. And some people think only one turn transition may not be that good. It's not that smooth. And some annotators think it's okay. So I think it depends on the annotator, definitely. But I think in the future, we can get them, we can customize for different scenario, especially based on the culture or their background.
Okay, thanks.
Thank you.
Yeah, thanks for a very nice talk. I think combining the different sources of information is very useful to help bring these pre-trained tools to be useful for real dialogue applications. I had a question about this last piece. There are a lot of dialogues that start off with small talk and then transition to some kind of task, but there are also other dialogues where things are not so clean, that there's a complete separation and a transition point. Sometimes you go back to the social chat in the middle of the task-oriented or afterwards. I wasn't clear on exactly, I think you're using the initial chit chat for finding the point and which task it is, but sometimes there's useful information in the chit chat that constrains some of the slots, filling in some of the slots, let's say, or putting constraints on what the preferences or requests of the user would be. So I was wondering if you thought about generalizing this a bit to more realistic or general combinations between open domain or chit chat and task oriented.
I see. I think that's a very good question because I checked with the prior work. Actually, there are several work try to combine these two different type of agents, like open domain and task-oriented. But actually, during the open domain chatting, they can involve the task-oriented part, which is based on the user already make the clear request. For example, during the chatting, and the user try to reserve a room, so you can use the task-oriented part to help them to finish this task. But the user already, in the beginning, user already has this intent, right? Yeah. But our scenario is that actually user do not have the clear intent. You want to guide the user through your business.
Right.
So this is not the direct help the user. You have your goal. You want them to follow your path to your business strategy. I think this is more important for companies. So I think this is the main difference between our work and also prior work.
Yeah, I don't know if you know the RIA project from Justine Cassell's lab, almost, I guess, 20 years ago now, but they talked about a real estate agent, and it was similar. I mean, there is maybe there's the user has a specific intent of, or a general intent, I guess, of finding a house, but what their specific information is maybe is a little more fuzzy. And so I think it's still, even with your very specific idea of guiding the user who doesn't have the prior intent, being able to merge different episodes of social dialogue and task-oriented might still be useful, I think, rather than just one transition to the task and no social talk after that.
Oh, I see. But in that scenario, the user already have the intent to buy the house, right? And you figure out the potential attribute for them. But in our scenario, probably the user don't know they want to buy the house. They just do check, and you figure out probably the user want to buy the house, and you suggest, do you want to buy the house, and so on, and you help them to buy the house. You want them to make the potential business in this scenario.
Hi, thanks for the talk. I was wondering if you could elaborate a bit on how the user simulator was built for the sales part. You said you simulated both the sides of the conversation. So if you could elaborate a bit on how you ended up doing that.
Excuse me, can you rephrase that?
Could you elaborate a bit on the user simulation part? You said you simulated both ends of the conversation for the sales part, right?
You mean the third part?
Yeah.
Actually, during our annotation for the quality, I think it's also be very difficult because we check the different dimension, but I only show the overall performance in our presentation. But actually, we check whether this transition turn is reasonable or not. Like, it should be early or later, or this is a good point, good timing to do the transition. So we also have the clear measurement about the timing, and also this transition turn is good or not. And the one I only show the overall conversations, and for specific part for timing and how to do the transition, I think the agreement is higher.
Sorry, I meant about the simulation part. So you simulated the data. So was that like a rule-based simulator, or did you end up using some kind of large language model to directly generate those utterances?
Okay. The simulation is based on the Blender bot. The Blender bot is the end-to-end model. So we have the Blender bot. It already focused on open domain chatting, but we also do fine-tuning for task-oriented dialogue. So this are not based on rule-based, it's neural models.
Okay, so you already had a data set of human-human conversations to fine-tune it on, or?
No, we use this Blender bot to generate the conversation by our own.
Gotcha. Thanks.
Hello, again, thank you for the very interesting talk. I actually have two questions. The first is, I just wonder, so the overall, in the human evaluation part, the overall quality, do you seek any inputs, let's say, from professional salespeople? Because my personal take is that a professional salesperson might have a different take on the overall quality of a sales pitch than the average M-Turker. Was my first question. The second is how much of context did you take into consideration, like 138 tokens for the sales pitch? Because I'm just thinking, if you start chit-chatting a bit too long, it might get beyond the certain limits of the language model in the input space. I'm just wondering, well, maybe this is more like implementation related question. But yeah, that's what my question is.
Okay, I see. Actually, for the first question, currently we do not limit the annotator's background. But you're right, we also get the feedback about getting the feedback from expert salesperson. So we are trying to collect the expert annotation for this project as well. And for the second one, actually, the conversation length, we have some constraint. So we only take the relatively short conversation in order, otherwise the annotator may not have enough patience to annotate that. So this is the, and it's not for a real scenario, but this for our annotation part, right? So, but I think for longer conversation can also work because you can just ignore like in the beginning of the conversation, it just only focus on the later part, the latest part, maybe enough. Thank you.
Hi, Vivian. My question / comment builds on David's question from earlier. Great work. This is very clever. I really like the way you're actually using these language models in a conversational and task-based way. As I've interacted with, I've done some projects as well with marketers, salespeople on chatbot related technology. And one thing that they're trying to solve is the problem of building the relationship with the customer. So in this, it's let's chat, task, and then done, it seems like. But my big question to you is what's next? Because if the conversational agent has another conversation with that person, and that person remembers that they had this conversation, it has to remember something about them. That's really important for marketers. Like if you in the chat, the chat part, a lot of information comes out. Like, I like going to movies, I like flowers, I like gardening, I have kids. This is my favorite sports team. That has to come up later when the next chat, when they have the next conversation, because if they forget them, they won't trust you anymore. So it's kind of me giving you a suggestion, but it's also asking you what's next for this work.
Yes, actually, it's just aligned with our plan because currently we can only detect the intent, right? But if we want to make the real like API call or the task-oriented bot, we need to have the slot information. The slot information, like the value, should come from some attribute through the chit chat, like what is the location they like, and also what kind of situation for their family. So we trying to incorporate the slot related values, try to extract this value from the open domain, because the current state tracker can only track the value from the task-oriented data set. And the value is very clear, but not implicit. But actually during our third project, the intent is implicit and also slot value are also implicit. We want to move further to the slot dimension. And also there's also a room for improvement to improve the recall of the implicit intent detector. Because currently, even though we use a knowledge graph, but we may not be able to detect two concepts which is very far away from each other. But a real sales expert, probably they can know, oh, there's some connection, and they try to move step further, so they can improve the recall to make big potential for business. So recall of the implicit intent detector is another dimension we want to improve.
Thanks so much. It's really interesting talk. And actually, I have two questions. The first one regarding the robustness. See the diagram with the 3 sentences, the labels is correct and the 1 is wrong. I'm just really curious about that part. Maybe I've missed that. Is what's the original quality of that ASR output, and because it makes sure it has some existing correct answers from the previous predictions, right? If what's the quality of that, and based on the new modules, how much it can be improved afterwards. That's my first question. And second question is following Casey's and David's questions is when I had conversations with the salespersons a couple of times as well previously, and there's a lot of strategies they learned when they train the salespersons to draft the conversations into their targets. But a lot of chances the users trying to get away from their strategies, trying to speak something differently, trying to not getting that product. I'm curious if you have think about anything, the strategies in the chit chat levels, not only the transactions between the chit chat to the task orientated. Thanks.
Okay. For the first question, actually we show the ASR performance, which is a little bit different by different data set. It's around 20 to 30%. And the reason why we have 3 sentences with one with the misrecognition, because in the SLU data set, usually you have the speech data and also the label, right? And in our scenario, if we do not have our own ASR, we just use the off-the-shelf one, and we put this speech through the system and then just output the text. But the text itself may not align well with the label. So that's why we have the label noise to deal with. And the speech recognition performance around 20 to 30%. And we also have the, let me slightly show this figure to you. And this table shows that we actually split the data by their recognition error. So if you have only text on the clean speech, you can see original Roberta will be perfect, right? Because there's no misrecognition you need to deal with. And for low, medium, and high error rate, our proposed model will improve more if you have higher error rate. So for multiple benchmark data. And for the high one, actually the error rate is above 40. I think it's a little bit too noisy to deal with. That's why the performance dropped into 57%.
Yeah, thank you for the interesting talk. I have a question about the simulated data in sales talk. So when I saw the example, I saw the chit chat part was somewhat social and enjoyable, while task-oriented part was a little bit cold. So how did you ensure that in the simulated data, the user and agent use the same like tone or word choice?
You mean the? Can you rephrase the
Oh yeah, sure. I saw some inconsistency in the word choice or tone in the examples, but when you generate the data, how did you ensure the consistency?
Actually, the inconsistency may happen between the task-oriented part with the open domain part, because it's very difficult to get, for example, the location, like previously mentioned Paris, and we need to know that Paris belongs to position in France. So we need to mention France, but in the task-oriented part, if we use another country, then the annotator will think it's very, very weird. So when we do the annotation, actually we replace it with the token. So we just say, oh, this is the city, this is the country. So we don't want the annotator focus on the inconsistent about the value side. And we can replace the slot value, like the value, and make it more consistent by post-processing. So the annotator will not focus on the inconsistency between the dialogues. But definitely there's a big issue to do. That's why we want to track the slot value in order to make it more consistent with the open domain part.
Well, I was actually trying to ask more like emotional aspect instead of like the object city, for example.
You mean the inconsistency between?
Inconsistency, I would say inconsistency within the same person or within the same agent.
You mean the tone?
Yes, yes, exactly.
I think there's not a problem because actually the original, like the model itself, it's the same model. So they should not be that inconsistent.
But you mix the data.
So
Should I give up?
Maybe you could take
Okay,
this
yeah.
in the coffee break. So we've
Later.
hit the time limit of this session. Thank you for all the questions and thank you for a very interesting talk.
Okay, thank you.
Thanks again to our speakers. So yeah, you will find various forms of caffeine and sugar in that direction. I'll be back in half an hour. Thank you.
Thank you so much.
I should now stop the video.